Hello and welcome to P.3. All the P lessons are like a review of intermediate algebra or beginning algebra topics, stuff that you should have seen before, and getting you ready for college algebra. So we're going to start with P3. And in P3, we're talking about um, radicals and rational exponents. So buckle up for that. Um, okay, radicals and rational exponents. Okay, so if you know anything about combining like terms, you treat radicals just like that. They have, in order to add subtract radicals, you need to be able to have the same radical on both terms. So on number one, I have radical 5 in both places, and so I can treat this as like a combining like term situation. In that case, I don't, as long as my radicals are the same, I put them in my answer and I add the numbers out front or subtract them. In this case, I'm going to add, but you could subtract just as well. So you have 3 plus 11, that's going to be 14 squared of 5. That's literally all you do. Now, uh, we say radicals because symbol, this symbol is pretty much ubiquitous, but it doesn't just apply to square roots. It applies to cube roots and fourth roots and fifth roots and stuff like that. And so you see, if you don't see a number, we're talking about a square root. But if you see a number, then like on number 11 or number 9, we're doing a cube root, something like that. And so oftentimes you'll hear it interchanged. A square root and cube root stuff is more specific, but a radical is talking about any of them. So just be clear about that. So on number 2, you'll see that I have the square root squared. So because that 2 is on the outside right there, that means I'm squaring the square root, right? That's the same thing as multiplying and dividing, like multiplying 1/5 by 5 or adding -2 to 2. Like it undoes what the original is trying to do. So when I see a square root squared, the inside, um, sorry, that 2 should be on the inside there. Okay. So I'm going to get rid of it, but I'm also going to, um, that's going to give me the square root of 81. Okay. Uh, because the square takes care of the -9. Okay, and then that is just 9. That is just 9. Okay, so sorry for the little switcheroo in the instructions there, but the 2 should have been inside the parentheses, not on. So now on 3, we know that 150. All right, so maybe you don't know that like 144 is 12 squared and 169 is 13 squared, and 150 falls in between those two. So that means it's going to be 12 point something. All right, but we're not interested in the decimal. We're interested in simplifying this we're simplifying a fraction. Okay, so how do you do that with a radical? Well, we're going to take this property idea that the square root of AB is equal to the square root of A times the square root of B. All right, we're going to use that to simplify this thing a little bit. Okay, well, we have 150. So what's this? What times what is 150? And we don't, there's several things that fit that category, but we don't want just anything. We want to deal with perfect squares because perfect squares get to come out of the radical. Like the square root of 9 is 3, and I can bring the 3 outside. Square root of 16 is 4, and I can bring the 4 outside. Okay, so think in terms of that. Well, if I do 25 times 6, that's 150, and 25 is a perfect square. So here's how that goes. This is going to be 25 times 6, and we'll split it up. 25 times square root of 6. All right, I can take the square root of 25. That's just 5. And then times square root of 6. Sorry, I can't do anything with the square root of 6 except add it to my answer. And so that is my answer, 5 square root of 6. Now, when you're multiplying, like it's uh, kind of like with fractions. There's more work that needs, or more consideration that needs to be taken in consideration when you're adding or subtracting fractions. But when you're multiplying, you're literally just multiplying across top, across the bottom. So on number 4, all you're doing is you're going to multiply one radical times the other, and you do it just like you would parentheses. So 3 times 6 is 18. X squared times x is x cubed. Okay, well, again, you can break this apart. Uh, First of all, is there a perfect square that goes into 18? Well, 9 goes into 18, so the answer is yes. So I'm going to rewrite this product. So if you've ever done like prime factorization, it's essentially what we're doing, but we're doing it in terms of perfect squares. Um, so I'm going to say 9 times 2, and then if I break the x squared or the x cubed into x squared times x, then I can take this out. So I can actually take out the 9 and the x squared, and whatever's left inside, I'll multiply together. So when I take the square root of 9, I get 3. When I take the square root of x squared, I get x. And then I'm left with 2x on the inside. So this is my simplified answer, 3x times the radical of 2x. And there you go. All right. When it comes to dividing fractions or dividing inside of a radical, what you're doing is you're going to take the radical, the square root of both top and the bottom. So what's the square root of 36? 6. What's the square root of 25? 5. And that's all you do. So you take the square root of the top of the fraction and the bottom of the fraction, and there's that. Now on 6, um, this one is they don't have the same radical when you start the problem. However, if you apply the same concepts we just talked about on where we simplify the radicals, we can take the square root of 8 and simplify it. Right? This is going to be the square root of 4 and 2. So I can take the 4 out and leave the 2. So that's going to be 2 square root of 2. And then I have the 6 square root of 2. And now I have something that I can add. And this is going to be 8 square root of 2. All right. Now on 7, we're doing it to both the square root of 12 and the 75. Okay, well, 6 is going to hang out for a second. This is the same thing as 4 and times 3 plus 5. This would be 25 and 3. So kind of use your common sense here and see that I'm going to be able to take the 4 out, leaving the 3. And I would like to do the same thing over here so that I have like terms I can add. So I would like to have 3 times something. Well, it turns out 3 times 25, 25 being a perfect squared, does give you 75. So this actually is going to work out. So I have a perfect squared here and here. I'm going to take them out. And so this is going to be 6 that I brought down times 2 radical 3. The 2 comes from the square root of 4. I took the 4 out. I'm going to do, I take the square root, and I get that, plus 5 times 5 radical 3. Okay. Now, um, when you multiply fractions like this, you're literally going to say 6 times 2. So that's going to be 12 square root of 3. 5 times 5 is 25. Okay. Now I have like terms. 12 times 20, 12 plus 25 is 37. It's going to be 37 square root of 3. And there you go. All right. Number 8. When it comes to problems like number 8, here's the deal. We can't um, we can't leave radicals in the bottom of a fraction. It's just frowned upon. And so we have this whole thing, this whole process called rationalizing the denominator that allows you to get rid of it. And it's essentially like multiplying by 1. And here's what we're going to do. We're going to multiply by the conjugate. Because there's more than one term on number 8 in the denominator, we have the square root of 5 and the negative 2. I'm going to multiply by what is the conjugate of this thing. And that means I'm going to multiply by the square root of 5 plus 2. Yeah, if you know anything about factoring, you know that when you factor a difference of two squares, um, there's two terms, both of them are squared, and it gives you um, two binomials where they're both the same except for a plus and plus in one and minus in the other. That's essentially what's going on here. This is going to be end up being a difference of two square situation. Okay, but if you struggle with that or factoring is not your favorite thing, all you're going to do is you're going to distribute. So I'm going to say 13 squared 5 plus um, 13 times 2 is 26. Okay, and then this is going to be square root of 5. I'm sorry, square root of 5 times square root of 5 is 5. Like everything works out, and I can just take the 5 out, right? And then square root of 5, sorry, square root of 5 times positive 2 is plus 2 square root of 5. And I have minus 2 square root of 5. And then I have minus 4. Okay, so a couple things happen here. My middle term is going to fall out, which is the whole thing I was trying to say earlier with the whole difference of two squares situation. you're going to um, end up with no middle term. But the beautiful thing about the conjugate situation is it knows about all this. It's going to get rid of your middle term, and you're going to end up with a whole number. Where you start with radicals, you're going to end up with a whole number. Okay, and now I have 5 minus 4, which is 1. And anything over 1, anything divided by 1 is itself. So it turns out that my new numerator um, is my answer. So not bad. Okay, on number 9, you're doing something simple, and that is you're going to rewrite this whole thing. And because this is the cube root, I need 3. Um, I need a set of 3 in order for it to come out of the radical. Well, essentially, how many times does 3 go into 22 even? Well, 7 times 3 is 21. So I can actually rewrite this as y to the 7th. Uh, and rewrite this as the cube root of y to the 21 times y. And then I can take the cube root of this and say y to the 7th cube root y to the first. Okay. On number 10, let's see. When you multiply radicals, you just multiply the insides together. So this is going to be the cube root of 40. Okay. But even though it's a cube root, we can still see if we can simplify. And so instead of looking for a perfect square, we're looking for a perfect cube. Okay, well, I can rewrite 40 as 8 times 5. And I do that because 8 is a perfect cube. 2 cubed is is 8. So that's how that works. So when I take this out, I can take the 8 out and take the cube root of it. And that's going to leave me with 2 cube root 5 as an answer. So you can simplify your radicals, whether it's a square root, cube root, fourth root, or whatever. It doesn't really matter. It just changes. It sets the rule, the index, or the whichever root you're dealing with sets the rules of the game. Okay. Number 11, I need to rewrite the insides so that I have um, like terms. Okay, well, let's see. Cube root. That's going to be. I'm going to say. I know that this is 8 and 2 times x times y cubed, and I know that I have a cubed here and here. So this is going to be the cube root. Or sorry, 2y. So this will be 2y cube root 2x. All right. Um, this one already has y up front. So minus y. Let's see. 128. That will be 16. What was that off the top of my head? Let's take a look. 128. Divided by 16. All right. 128 divided by 8 is 16. So this, I could do 64. 128 divided by 64. All right. 64 is perfect cubed. So let's do 64 times 2 times x. All right. 64 is 4 cubed. So I'm going to take that out. That's going to be 4y cube root 2x. Now, just like getting a common denominator, I now have common radicals, and I can combine like terms. You have 2y cube root 2x minus 4y cube root 2x. So essentially 2y minus 4y, which is going to give you a negative 2y cube root 2x. Okay. All right. Fractional uh, exponents or rational exponents. So a couple things here. If I have whatever the denominator is, that's the root that I'm taking. And I can rewrite this as 3 the cube root of 125 all squared. So I can write it like this, or you can write it like this, or the cube root 125. You put the square on the inside. And it really is a situational thing, which method you prefer, or which one is going to work out. In this situation, it would make sense to use the first one, to take the cube root of 125 first. And if I did that, that would be 5 squared. And then I can get 25 real quickly out of that. Sometimes you need to square it or first. So in this situation, it wouldn't have mattered. You could have squared first, 125 squared, and then cube rooted it, but that's not necessary. Um, if you can take the cube root of whatever number is there, then makes your number smaller. And so that's what I recommend. Now, if there's a 1 in the fraction, then that just means I'm taking that root, the cube root, square root, or whatever, and there's nothing else special about it. Okay, so on 13, it says everything's raised to the fourth power. That means I'm taking the fourth root of everything. Okay, well, the fifth root or the fourth root of 625 is 5. It's 5, 25, 125, 625. 625 is 5 to the fourth. So um, we have a calculator policy. So there's no certain calculators you can use. I'm not going to give you calculator tips in this video because not everybody uses the same one. But if you have questions about how to do this in your calculator, if you have a scientific calculator, you can totally do the fourth root. If you need help with that, come see me or schedule a Zoom call and we'll walk you through it. But yeah, this is totally going to be 5 to the fourth is the fourth root. So this is going to be 5. And then when you raise a power to a power, even if it's a fractional exponent, you multiply. So 16 times the fourth is 4. So x to the fourth, y to the fifth. Okay, there's that. Now, on 14, remember, based off 13, I can rewrite this as x to the 10th raised to the 1/5. And maybe that's easier for you to see. But 10 times 1/5, or 10 divided by 5 is 2. And so my final answer here is going to be x squared. Okay. Okay. Last problem. So we have this negative exponent, this negative fractional exponent. Well, the negative is just going to change the position. So if I had the negative in the numerator, then I'm going to take the entire thing and move it to the bottom. And so that's what I'm going to do here. Is I'm just going to rewrite this. I'm not going to do anything special, but I'm going to rewrite this x y to the 1/4 over 16 x to the negative 4 y to the 8th 1/4. Okay. So that negative exponent is dealt with first. And now I would do, you could have multiplied through to begin with to figure that out, but it's all good. Now that we have this here, this is going to be x, y to the 1/4. 2 to the fourth is 16, so that's going to be 2. It's going to be x to the negative 1, y squared. Now we still have this negative 1 here in our exponent, which we can't deal with. So we're going to finish this problem by moving this x to the negative 1 up, which means we're going to have x to the first times x to the first, which is going to be x squared, y to 1/4 over 2 y squared. All right, I don't need multiple y's. So 2 is bigger than 1/4. So I'm gonna rewrite this um, with the y at the bottom. So this is going to be x squared over 2 y squared times y to the negative 1/4. Now, I did this because it may not be obvious to you, but when you multiply like bases, you add the exponents. And when you have opposite signs, you're subtracting essentially. So 2 plus negative 1/4 is the same thing as saying 2 minus 1/4. So you need to convert or do that little conversion of what is a new fraction going to be? What is 2 in terms of 4? Well, that's going to be 8 over 4 times y to the negative 1 over 4. And then that is going to give you a final answer of x squared over 2y to the 7/4. See, nothing like a lot of fractions to end the day on. So this is your answer. If you have any questions about this particular problem or anything in P3, please reach out. Um, whether it's calculator tips or just problems that you want to work on, reach out, and I'll see you in the next video.